Okay, so this video is going to be on the discriminant of a quadratic. So we'll just take that heading down, and just a reminder that part of your the expectations I have of you for prep is to watch this video, but also to take notes. Discriminant of a quadratic. Okay, so what is the discriminant of a quadratic? Well, we've got we need to be familiar with the general term for a quadratic equation. Y equals ax squared plus bx plus c, and then from that, if we want to find the x-intercepts, which we often do, making y equal to 0, then we look at solving the equation ax squared plus bx plus c equals 0. And in order to do that, we might use the quadratic formula, which which we'll start with. So just to make a note there, for x-intercepts, make y equal to 0, and so what we're after therefore is to solve ax squared plus bx plus c is equal to 0. These are for the x-intercepts, so that when we've got a parabola, we can find out what these values here are, which are often of great interest to us. Now, the last section was on the quadratic formula, and the quadratic formula excuse me, indeed solves this for us. It solves this quadratic for us in this way: minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now what the discriminant does is it concentrates on this part of the quadratic formula here, the b squared minus 4ac, because the value of b squared minus 4ac determines what type of solutions we're going to get, and that is what the discriminant is concerned with, is finding out what type of solutions a quadratic has. So the number here under the square root sign will tell us and will determine and discriminate between the types of roots, if there are any in fact, of the quadratic equation. So for instance, just to run through it quickly, if this were negative, for instance, if b squared minus 4ac were negative, we'd be trying to take the square root of a negative number, which we all know is a problem. We can't do it, so there would be no solution to that, and therefore we would have no roots, no x-intercepts, and the parabola would look like so if there were no solution. So that would be if the discriminant was less than 0, this value here. If it's greater than 0, then yes, we're going to have x-intercepts. But we're going to have a look at the three scenarios, the three cases of values of the discriminant. So the discriminant is that value in there. It's called the discriminant. It's equal to b squared minus 4ac, and that value is of great interest to us. And there's a symbol for the discriminant. It's this little triangle. So we're going to start using that from now on. The discriminant is b squared minus 4ac. Okay, so let's have a look at the three cases. Case 1, the discriminant, which is the little triangle, is less than 0. So that means that we are trying to take the square root of a negative number. We cannot do that. So the result of the discriminant being less than 0 is that there are no x-intercepts, because there's no solution. When we're trying to solve this quadratic equal to 0, we're trying to find the value of the x-intercepts. If we don't get a value for that, then we can conclude that there are no x-intercepts. So just for your notes, I'm going to rub these out because they're not connected to anything at the moment, but this first case is our parabolas are not intersecting with the x-axis, so they would look something like this. If the discriminant is less than 0, these are the graphs that would result. This would be for a is greater than 0, this value here, the leading coefficient, greater than 0, concave up. This would be a is less than 0. We might just make a little note of that. A is less than 0, a is greater than 0. Okay, so case 1, discriminant less than 0. Case 2, now discriminant is equal to 0. Now if the discriminant is equal to 0, let's have a little think about this. We're going to put a 0 in there. We're now looking at minus b plus or minus square root of 0. Now the square root of 0 is 0. So this plus or minus 0, well, they're going to give us the same result. So we're only going to have one solution, and that will be minus b over 2a. So for case 2, the discriminant is equal to 0. There's one x-intercept. And that's the example where you see the parabola just touch the x-axis, either for a is greater than 0. Remember, a is the value of the coefficient of x squared, or a is less than 0. So that's a graph of a parabola that has a discriminant equal to 0 will look like this. And I guess the most common example, and certainly of the ones that we look at, case 3, the discriminant is greater than 0. Now that is going to give us a value here that allows us to get a plus minus, allows us to get two different values when we take into account this plus minus. So we will get two solutions. We'll get two x-intercepts. And I guess this is the type of parabola we're most familiar with. Two x-intercepts. So we are going to have a parabola that dips below or above the x-axis, like so, if a is greater than 0, and like so, if a is less than 0. We're going to have two solutions. So there are three cases for a discriminant, or calculating a discriminant. It has to fall into one of those three categories. And if we are looking at just finding out what the nature of the intercepts are, then it's just the discriminant. We're not finding out the actual x-intercepts, we're finding out the nature of them. Are they 0? Are they 1? Are they 2? And so that's the focus on this section. We might just have a look at, in case 3, there are two scenarios we want to have a look at with case 3. Case 3 part 1, when the discriminant is greater than 0, and also a perfect square. So it's a positive number, but it's also a perfect square. Now have a think about that as we go back and have a look at the quadratic formula. If we put a perfect square number in here, like 25, square root of 25, that's 5, and we're going to have a rational solution. We have two rational solutions. Rational numbers meaning fractions, whole numbers. If it's also a perfect square, we will get two rational x-intercepts. Two rational x-intercepts. It will also imply, for interest, this is quite important also, it's quite useful, if we do get a perfect square here for our b squared minus 4ac, then the quadratic is factorizable. And that's worth noting. Quadratic also factorizable. Sometimes it's worth working out the discriminant if you're trying to factorize. If you're not sure whether a quadratic is factorizable, work out the discriminant. If it's a perfect square, it is. The second case there is that of the discriminant greater than 0, but not a perfect square, then we get we will get to irrational x-intercepts. So irrational meaning it's a surd and we can't reduce it to a whole number. Okay, let's do a couple of examples. Let's have a look at each case. So example 1 is calculate the discriminant and find the number of solutions or x-intercepts, or roots is another word for this. So example, find the discriminant and hence the number of x-intercepts, but this also comes up as roots of an equation, and also it's the same thing, x-intercepts. So find the discriminant and hence the number of x-intercepts for the following quadratics. Okay, first one, y equals 2x squared minus 5x plus 3. Okay, so now we're asked to find the discriminant. So let's find the discriminant. That's the symbol for the discriminant, b squared minus 4 times 2 times 3. Now those little dots there, I'm using those instead of multiplication signs. Minus 5 to the power of 2, that's 25. Minus 4, 2 is 8, 3 is 24. So 25 minus 24, it's 1. The discriminant is equal to 1. So it's greater than 0, and it's also a perfect square. So we're going to get 2 rational x-intercepts from this. 2 rational, not celebrating the x-intercept roots, it's quicker. And rational, this gives us a bit more information. So 2 rational roots from part 1, and that's all. We're not finding out actually what the roots are, we're just finding out the nature of them, the type of solutions that we get. Part example 2, y equals 3x squared plus 4x plus 2. So the discriminant again is equal to b squared. That's b squared is 4 squared minus 4 times 3 times 2. Now that's equal to 16 minus 24. Hold on a second, that's equal to minus 8. That's less than 0. That means that I have no real roots, no solutions, no x-intercepts. There are 0 x-intercepts. So there's some different ways of saying that, but essentially when the discriminant is less than 0, we don't have any solutions. Example 3, y equals 4x squared plus 4x plus 1. Let's see if we can come up with the third type of discriminant value here. In this case it's 4 squared, b squared minus 4 times 1, 16 minus 16, well that's 0. The discriminant is 0, that means we have 1 x-intercept, 1 solution, 1 root. So there are examples. In summary, the discriminant is focused on this part of the quadratic equation, on what's underneath the square root sign, because the value of that number there will determine what type of solutions, what type of x-intercept, what type of solutions to our quadratic we are going to get. And typically when you are looking at discriminant, you are not solving, you're not finding out the actual x-intercept or the solution, you are finding just the nature of it, the type of it. It's quite a useful thing to know. Okay, well, we're just about ready now to tackle exercise 4R on page 124, and that will be for us in class tomorrow. Over now.